All right, our journey to master Docker begins here. In every section, we're going to discover something new about Docker. In this section, we're going to talk about what Docker is and why it's so popular. Then we're going to talk about virtual machines and containers. Next, we're going to talk about the architecture of Docker so you understand how it works. Then we're going to install Docker and get our hands dirty. I'm going to give you an overview of your development workflow with Docker, and then we're going to see that in action using a really simple example. So by the end of this section, you will have an idea of what Docker is all about. I'm so excited about this section. I hope you are too. So let's jump in and get started. So what is Docker and why is everyone using it these days? Well, Docker is a platform for building, running, and shipping applications in a consistent manner. So if your application works on your development machine, it can run and function the same way on other machines. If you have been developing software for a while, you've probably come across this situation where your application works on your development machine, but doesn't somewhere else. Can you think of 3 reasons why this happens? Well, this can happen if one or more files are not included as part of your deployment. So your application is not completely deployed. It's missing something. This can also happen if the target machine is running a different version of some software that your application needs. Let's say your application needs Node version 14, but the target machine is running Node version 9. This can also happen if the configuration settings like environment variables are different across these machines. And this is where Docker comes to the rescue. With Docker, we can easily package up our application with everything it needs and run it anywhere on any machine with Docker. So if your application needs a given version of Node and MongoDB, all of these will be included in your application's package. Now you can take this package and run it on any machine that runs Docker. So if it works on your development machine, it's definitely going to work on your test and production machines. Now there's more. If someone joins your team, they don't have to spend half a day or so setting up a new machine to run your application. They don't have to install and configure all these dependencies. They simply tell Docker to bring up your application, and Docker itself will automatically download and run these dependencies inside an isolated environment called a container. And this is the beauty of Docker. This isolated environment allows multiple applications use different versions of some software side by side. So one application may use Node version 14, another application may use Node version 9. Both these applications can run side by side on the same machine without messing with each other. So this is how Docker allows us to consistently run an application on different machines. Now there's one more benefit here. When we're done with this application and don't want to work on it anymore, we can remove the application and all its dependencies in one go. Without Docker, as we work on different projects, our development machine gets cluttered with so many libraries and tools that are used by different applications. And then after a while, we don't know if we can remove one or more of these tools because we're always afraid that we would mess up with some application. With Docker, we don't have to worry about this. Because each application runs with its dependencies inside an isolated environment, we can safely remove an application with all its dependencies to clean up our machine. Isn't that great? So, in a nutshell, Docker helps us consistently build, run, and ship our applications. And that's why a lot of employers are looking for people with Docker skills these days. So if you're pursuing a job as a software or DevOps engineer, I highly encourage you to learn Docker and learn it well. And that's exactly what this course is all about. I'm going to take you on a journey and teach you everything you need to know about Docker so you can use it like a pro. No copy pasting commands here. So in the last lesson, I briefly talked about containers. A container is an isolated environment for running an application. Now, one of the questions that often comes up is, how are containers different from virtual machines or VMs? Do you know the differences? Well, a virtual machine, as the name implies, is an abstraction of a machine or physical hardware. So we can run several virtual machines on a real physical machine. For example, we can have a Mac, and on this Mac, we can run 2 virtual machines, one running Windows, the other running Linux. How do we do that? Using a tool called hypervisor. I know, it's one of those computer science names. In simple terms, a hypervisor is software we use to create and manage virtual machines. There are many hypervisors available out there like VirtualBox and VMware, which are cross-platform, so they can run on Windows, macOS, and Linux, and Hyper-V, which is only for Windows. So with a hypervisor, we can manage virtual machines. Now, what is the benefit of building virtual machines? Well, for us software developers, we can run an application in isolation inside a virtual machine. So on the same physical machine, we can have two different virtual machines, each running a completely different application, and each application has the exact dependencies it needs. So application 1 may use Node version 14 and MongoDB version 4, while application 2 may use Node version 9 and MongoDB version 3. All these are running on the same machine, but in different isolated environments. That's one of the benefits of virtual machines. But there are a number of problems with this model. Each virtual machine needs a full copy of an operating system that needs to be licensed, patched, and monitored. And that's why these virtual machines are slow to start, because the entire operating system has to be loaded, just like starting your computer. Another problem is that these virtual machines are resource intensive because each virtual machine takes a slice of the actual physical hardware resources, like CPU, memory, and disk space. So if you have 8 gigabytes of memory, that memory has to be divided between different virtual machines. Of course, we can decide how much memory to allocate to each virtual machine, but at the end of the day, we have a limit in terms of the number of VMs we can run on a machine. Usually a handful, otherwise we're going to run out of hardware resources. Now let's talk about containers. Containers give us the same kind of isolation, so we can run multiple applications in isolation, but they're more lightweight. They don't need a full operating system. In fact, all containers on a single machine share the operating system of the host. So that means we need to license, patch, and monitor a single operating system. Also, because the operating system has already started on the host, a container can start up pretty quickly, usually in a second, sometimes less. And also, these containers don't need a slice of the hardware resources on the host. So we don't need to give them a specific number of CPU cores or a slice of memory or disk space. So on a single host, we can run tens or even hundreds of containers side by side. So these are the differences between containers and virtual machines. Let's talk about the architecture of Docker so you understand how it works. Docker uses a client-server architecture, so it has a client component that talks to a server component using a RESTful API. The server, also called the Docker engine, sits in the background and takes care of building and running Docker containers. Now, technically, a container is just a process, like other processes running on your computer, but it's a special kind of process which we're going to talk about soon. Now, as I told you, unlike virtual machines, containers don't contain a full-blown operating system. Instead, all containers on a host share the operating system of the host. Now, more accurately, all these containers share the kernel of the host. What's a kernel? A kernel is the core of an operating system. It's like the engine of a car. It's the part that manages all applications as well as hardware resources like memory and CPU. Every operating system has its own kernel or engine, and these kernels have different APIs. That's why we cannot run a Windows application on Linux, because under the hood, this application needs to talk to the kernel of the underlying operating system, okay? So that means on a Linux machine, we can only run Linux containers because these containers need Linux. On a Windows machine, however, we can run both Windows and Linux containers because Windows 10 is now shipped with a custom-built Linux kernel. This is in addition to the Windows kernel that's always been in Windows. It's not a replacement. So with this Linux kernel, now we can run Linux applications natively on Windows. So on Windows, we can run both Linux and Windows containers. Our Windows containers share the Windows kernel, and our Linux containers share the Linux kernel, okay? Now, what about macOS? Well, macOS has its own kernel, which is different from Linux and Windows kernels, and this kernel does not have native support for containerized applications. So Docker on Mac uses a lightweight Linux virtual machine to run Linux containers. All right, enough about the architecture. Next, we're going to install Docker, and that's where the fun begins. All right, now let's install the latest version of Docker. If you have an existing version of Docker on your machine, I highly encourage you to upgrade to the latest version because your version might be old and not compatible with the version I'm using in this course. So here I'm using Docker version 20.10.5, okay? So to get Docker, go to this page, docs.docker.com/getDocker, or you can just Google get Docker or install Docker. Now on this page, you can see instructions for downloading and installing Docker Desktop for Mac and Windows, as well as Docker Engine for Linux. So on Mac and Windows, we have Docker Desktop, which is the combination of Docker Engine plus a bunch of other tools. At the time of recording this, we don't have Docker Desktop for Linux. We only have the Docker Engine. But of course, that might change in the future. So a couple of notes for my Mac and Windows users. Let's go to this page. So over here, you can download the latest version from Docker Hub. But before doing this, I highly encourage you to go through system requirements and make sure your computer satisfies these requirements. Otherwise, you might encounter weird issues. So the installation is pretty straightforward. When you go to this page, you're going to download a DMG file. Just drag and drop this onto the applications folder and then start it. This is very important. A lot of people miss that step. So when you start Docker Engine, by double clicking on this application, you're going to see the Docker icon on the top status bar. If you don't see this, Docker Engine is not running and there's nothing you can do. So you have to wait for this to start. The same applies to my Windows users. So back to this page. Let's look at the instructions for Windows. So once again, you can download the latest version from Docker Hub. But once again, make sure to read system requirements. One of the things that is really important is enabling Hyper-V and containers Windows features. So I don't have a Windows machine to show you here, but just go to the page where you can turn on or turn off Windows features. There, make sure you have enabled Hyper-V and containers. It's pretty straightforward, but if you can't find it, just Google it. I'm pretty sure there are tons of articles out there. Also, at the end of the installation, you might get an error saying WS2 installation is incomplete. Basically, what this error is saying is that you need to upgrade the Linux kernel that is shipped with your Windows. So just click on this link. This is going to take you to this page on Microsoft.com where you can download the latest Linux kernel. So just click on this link to get an MSI file, run it, and then you have to restart your computer. Now, once your computer is restarted, you need to wait a little while until Docker Engine is started. Depending on your machine, this might take several seconds or up to a minute. So wait a little while, then open up a terminal window and run Docker version. So over here, you can see the version of the client and the server. If the server, which is Docker Engine, is not running, you're not going to see this information. And this applies to all operating systems, Windows, macOS, and Linux. So make sure Docker Engine is running before going forward. If you encounter any errors, you can post your question on our forum at forum.codewithmosh.com. Or if you want a faster response, just Google the error message. I'm pretty sure hundreds of people have encountered the same problem as you. Now let's talk about your development workflow when using Docker. So to start off, we take an application. It doesn't matter what kind of application it is or how it's built. We take that application and Dockerize it, which means we make a small change so that it can be run by Docker. How? We just add a Docker file to it. A Docker file is a plain text file that includes instructions that Docker uses to package up this application into an image. This image contains everything our application needs to run. Everything. Typically, a cut down operating system, a runtime environment like Node or Python. It also contains application files, third-party libraries, environment variables, and so on. So we create a Docker file and give it to Docker for packaging our application into an image. Once we have an image, we tell Docker to start a container using that image. So a container, as I told you, is just a process, but it's a special kind of process because it has its own file system, which is provided by the image. So our application gets loaded inside a container or a process, and this is how we run our application locally on our development machine. So instead of directly launching the application and running it inside a typical process, we tell Docker to run it inside a container, an isolated environment. Now here's the beauty of Docker. Once we have this image, we can push it to a Docker registry like Docker Hub. Docker Hub to Docker is like GitHub to Git. It's a storage for Docker images that anyone can use. So once our application image is on Docker Hub, then we can put it on any machines running Docker. This machine has the same image we have on our development machine, which contains a specific version of our application with everything it needs. So we can start our application the same way we started it on our development machine. We just tell Docker to start a container using this image. So with Docker, we We no longer need to maintain long, complex release documents that have to be precisely followed. All the instructions for building an image of an application are written in a Docker file. With that, we can package up our application into an image and run it virtually anywhere. This is the beauty of Docker. Next, we're going to see this workflow in action. In this lesson, I'm going to walk you through a typical development workflow. Now, don't try to memorize anything in this lesson because I just want you to see the big picture. So everything I show you in this lesson, we're going to cover in depth later in the course. So here in this terminal window, I'm currently on my desktop. I'm going to create a new directory called Hello Docker, then go inside this directory and open it in Visual Studio Code. So I'm going to use VS Code as my editor, but you can use any editor that you prefer. Okay. Now in this directory, I'm going to add a new file called app.js. We're going to write one line of JavaScript code. You don't have to be a JavaScript developer. You don't even need to learn JavaScript. So just follow along with me. So here we're going to write console in lowercase .log hello Docker. So with this, we're going to print a message on the terminal. Let's say this is an application and we want to Dockerize this application. So we want to build, run, and ship it using Docker. So typically without Docker, if you want to ship this application or more accurately, this program to a different computer, on that computer, we need to install Node, and then we can go to the terminal and type node app.js. So we get the output. So here are the instructions for deploying this program. We need to start with an operating system. Then we need to install Node, which is an execution environment for JavaScript code. Next, we need to copy our application files. And finally, we need to run node app.js. So we have to follow 4 steps just for a simple program. What if we were working with a really complex application? You would end up with a complex release document that had to be precisely followed. Now, this is where Docker comes to the rescue. We can write these instructions inside a Docker file and let Docker package up our application. So back to VS Code, we're going to add another file to this project called Docker file. So capital D and all the other letters are lowercase, and this file doesn't have any extensions. Okay. Now, VS Code is asking if you want to install the recommended extensions for Docker. We can go ahead with that. Good. So back to this Docker file. Here we write instructions for packaging our application. So typically we start from a base image. This base image has a bunch of files. We're going to take those files and add additional files to it. This is kind of like inheritance in programming. Okay. So what is the base image? Well, we can start from a Linux image and then install Node on top of it, or we can start from a Node image. This image is already built on top of Linux. Now, how do I know these names? Well, these images are officially published on Docker Hub. So if you go to hub.docker.com and search for Node, you can see the official Node image here. So Docker Hub is a registry for Docker images. Now back to our Docker file. So we start from a Node image. Now, if you look at Docker Hub, you will see that there are multiple Node images. These Node images are built on top of different distributions of Linux. So Linux has different distributions or different flavors used for different purposes. Now here we can specify a tag using a colon to specify which Linux distribution we want to use. For this demo, I'm going to use Alpine, which is a very small Linux distribution. So the size of the image that we're going to download and build on top of is going to be very small. Okay. So we start from that image. Then we need to copy our application or program files. For that, we use the copy instruction or copy command. We're going to copy all the files in the current directory into the app directory into that image. So that image has a file system, and in that file system, we're going to create a directory called app. Okay. Now, finally, we're going to use the command instruction to execute a command. What command should we execute here? Node app.js. But this file is inside the app directory, so we have to prefix it with the directory name. Alternatively, here we could set the current working directory, workdir, to /app, and then we don't need to prefix this with the directory name. So when we use this instruction, all the following instructions assume that we're currently inside the app directory. Okay. So these instructions clearly document our deployment process. Now, we go to the terminal and tell Docker to package up our application. So we say Docker build. We need to give our image a tag to identify it. So -t. Here we specify a name like hello Docker. And then we need to specify where Docker can find a Docker file. So we're currently inside hello Docker directory, and our Docker file is right here. So we use a period to reference the current directory. Let's go with that. Now you might be expecting an image file inside the current directory, but back in VS Code, look, there is nothing here because the image is not stored here. And in fact, an image is not a single file. How Docker stores this image is very complex and we don't have to worry about it. So back to the terminal. To see all the images on this computer, we type Docker images or Docker image ls, which is short for list. So take a look. On this machine, we have a repository called hello Docker. In this repository, we have an image with this tag, latest. So Docker added this by default. We'll talk about this later in the course, but basically we use these tags for versioning our images. So each image can contain a different version of our application, okay? Now, each image also has a unique identifier. Here we can see when the image was created and the size of this image. So because we used Node from Linux Alpine, we ended up with 112 megabytes of data in this image. So this image contains Alpine Linux, Node, and our application files. And the total size is 112 megabytes. Now, if we used a different Node image that was based on a different distribution of Linux, we would end up with a larger image. And then when deploying that image, we would have to transfer that image from one computer to another. So that's why we use Node Alpine, because this is a very small image, okay? So we have built this image. Now we can run this image on any computer running Docker. So on this machine, which is my development machine, I can say Docker run, and then type the image name, hello Docker. And it doesn't matter which directory I'm in, because this image contains all the files for running our application. Now, look, we see the message on the terminal. Now, I can go ahead and publish this image to Docker Hub, so anyone can use this image. Then I can go on another machine, like a test or a production machine, and pull and run this image. In fact, I've done this before recording this video. So back to Docker Hub, look, I have this repository, code with mosh /hello Docker. Now we can take this image and run it on any computers. Let me show you something really cool. So let's search for play with Docker. Let's go to this page and log in. Here we need to sign in with our Docker ID. Anyone can create this ID on docker.com. So let's go ahead and start a lab. Over here, we can start a new virtual machine. So let's add a new instance. Now, this virtual machine is a blank machine. It only has an operating system, which is Linux, and Docker. So in this terminal window, if we type node, look, node command not found. So node is not installed here. But because we have Docker, we can pull and run the image that I published on Docker Hub. So let me maximize this window by pressing Alt and Enter. First, let's run Docker version. So on this machine, we're running Docker version 20.10.0. So to pull and run my program, first we type Docker pull, code with mosh /hello-docker. All right, Docker downloaded this image. We can verify it by typing Docker. What command should we run here? Docker images or image ls. So on this machine, we have this repository, code with mosh /hello Docker. And this repository contains a single image with this tag, latest. So now we can run this application exactly the same way we ran it on my development machine. So from any directory, we can type Docker run code with mosh /hello-docker. And here's the message, beautiful. Of course, I had to cut this down in editing. It took a little while to start this application on this very slow virtual machine, but you got the point. So we can take any application and Dockerize it by adding a Docker file to it. This Docker file contains instructions for packaging an application into an image. Once we have an image, we can run it virtually anywhere on any machine with Docker.